Well, hey everybody, welcome back to Tech Talk Video. This video is about something most of us probably didn't like very well in school, math, but it is important for you to understand that there are 4 different types of numbering systems when we're working in IT, and so it's going to be important for you to know all of them. Let's get started. Okay, now I am going to use Google Docs, specifically a program that Google created called Google Sheets. I'm going to do everything we're doing here in a spreadsheet. You could do this in Microsoft Excel as well, and there are some advantages that a spreadsheet brings to you that will help you figure out how to calculate all these different number systems. But before we do that, I want to show you first what the number systems are. So this first one is called decimal. This is the one that you learned in school, counting by tens, 10, 20, 30, and so on. The next one is binary. This is base 2. So decimal is a base 10, meaning we count by tens. Binary is a base 2, meaning that we count by twos. The reason this is significant is because at the end of the day, when computers are sending out things over the wire, it is strictly on or off. The bits are either on or they're turned off. We say that the bits are flipped or they're not flipped. And so binary is extremely important to us. Next, we have a thing that's very common. It's called hexadecimal. You'll find this used, hexadecimal is used to denote computer memory, for example. It's used in setting colors in a web development environment and things like that. And hex is a base 16 system, so we count by 16s. Finally, there is an octal system. This is base 8, and we count by 8s. And actually, in the Linux world, this has some import, very strange import too, but I do want to show you how octal works so that when you encounter it in Linux, you'll know what we're looking at. So let's get started. So the first thing I want you to know about is a thing called autofill. These spreadsheets have an autofill characteristic, which is really cool. I like it a lot. Let me show you what I'm talking about. So here in the cell here, I don't know if you've used spreadsheets before, but we have columns which are vertical, rows which are horizontal, and the intersection of a column and a row is called a cell. And right now we're in cell A2. What we want to do is we want to start typing in numbers. 1, I'm going to go down, 2, down, 3, down. Now what I do is I highlight those numbers. So I'm just going to come up and grab the number 1 here, hold down the shift key, and arrow down to the other 3 numbers. Now I'm going to use autofill, and you can see this little square box right on the bottom right corner of my cells here. I'm going to drag that down, and I want to get to the number 256. So I'm just going to watch this screen scroll down. You can see it with me. And I want to stop when it gets to number 256. What will happen is Google Sheets will autofill each of these cells with one number right after the other. It's the coolest feature ever. Microsoft Excel had this several years ago, and I noticed that Google Sheets has actually put it up a little bit, put it on steroids. Works really well. By the way, when you're working in Excel, you will see it count those numbers off to the right of your mouse, but in Google Sheets, you do not see that. I'll let go. There they are. Now here's your magic number, 255. Why is this important? Well, we're going to be talking about what is called 8-bit math, and I'll show you that in just a minute. I'll show you what the bits look like. But before we do that, I want you to know that when we're working with decimal base 10, the last number we can get in 8-bit binary is 255. Then we can go from 0 to 255, from 1 to 255. 0 means off, of course, here. So I've got 1 through 255. 255 is the very last number we can get out of base 10. Let's talk about binary now. Now here's one of the magic features of worksheets. You can go and use what is called a function and it will automatically convert these numbers into binary, for example, or hex, for example, which a lot of people, that's short for hexadecimal, or octal. And I'll show you how that works. And the command is identical in both Excel and in Google Sheets. It's a little bit cooler in Google Sheets, and I'll show you why. So the first thing you need whenever you're going to type in a function in Excel or in Google Sheets is you type in the equal sign, so equal. Now we think about what we want to do. We want to convert decimal to binary. So there's a function called des to binary. Look at that. It seems to know what it is we want. I'm going to select this. Now you have a left parenthesis, so it says equal des to bind, left parentheses. You can use your arrow keys to point to the cell you're interested in highlighting. So I'm going to do that. I'm going to hit my left arrow and point to decimal number 1 here. Now in this case we're talking about 8-bit binary. So I'm going to put in a comma here because I wanted to carry this math out 8 significant digits. And I'll type in an 8, and then I will type in a parentheses to get the equation finished off. This is called a function, and the function we're using is called des to bind, and we're telling it that we want to apply des to bind starting at A2. Oops, I've got a star in there, I'm in at 8. Starting at A2, and it shows you the result. Look at that, that's very cool. This is even cooler. When you hit the enter key, Google Sheets sees that you've already done an autofill like automobile, autofill from 1 to 255. It says, hey, do you want me to fill that for you as well? Yes, let's do that. Okay, so here's binary. It starts out at 1. I'll explain this in a while. And we go clear down to the bottom to 255. I'll have my page down to get there a little faster. Look at this. This is very important. 255 in binary is the same as 1111, 1111 in 8-bit binary. What it means is that all of the bits are flipped. They can all use electricity. Now in my classroom, I have an 8 light switch thing. I have a board that has 8 light switches on it, and if I flick each one on, I can say, well, this bit's been turned on. The allegory is pretty close, because when you're working with transistors inside computers and logic gates, these bits get flipped, they get turned on, and they get power supplied to them. So that's the reason we're so interested in binary. I'm going to go home with a control home. Now let's do hex. Now, as you might imagine, there is a conversion function for hexadecimal. So I type in equal des to, oh, look at here, there's des to hex. Beautiful. Okay, I'm going to go hit enter. I'm going to point again to my decimal number right here, A2. I want it to convert A2 to hexadecimal, comma, and I only need to carry this out to 2 places because hexadecimal is a space-saving counting system. It counts in 16s, so the maximum we're going to get to in hex is FF. So I'm going to type in 2 places, put in my right parentheses, and it shows you that it's going to start out at 0, 1, which is like all of them. I hit enter, it sees the fill. I'm like, yes, go ahead and fill that. Page down, and I want to show you something that's interesting here. Hexadecimal starts at 1, 2, 3, 4, 5, 6, 7, 8, 9, but it doesn't use 10 yet. It will use 10, but it doesn't use 10 yet. It goes with A, B, C, D, E, F, and now the number 10. That's weird, right? So that's 16 numbers. This whole block is 16 numbers. That's what hexadecimal does. Now look, it starts at 10. 11, 12, 13, 14, 15, 16, 17, 18, 19. Let me scroll up and get a little and get some space for you. Now instead of 10, it says 1A, just like 11, 12, 13, 1B, 1C, 1D, 1E, 1F, 20. And the same thing, 21, 22, 23, 24, 25, 26, 27, 28, 29. 2A, 2B, 2C, 2D, 2E. Now there's another thing I want to tell you, and I'll put the link below in the video. I like to use the aviation, excuse me, I made that go away. I like to use the aviation phonetic alphabet. I'll post the link to it for you. But the reason that you use that is to make your letters absolutely clear. And I love it because when I'm working with memory addresses or whatever, there are all these letters strung together. And it might be hard for a student of mine or myself to hear the letter correctly, or maybe I don't pronounce it very well. So I use the phonetic alphabet. So A is alpha, B is Bravo, C is Charlie, D is Delta, E is Echo, F is Foxtrot. Let me do what I do in class for kids. Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, Golf, Hotel, India, Juliet, Kilo, Lima, Michael, November, Oscar, Papa, Romeo, Quebec, Sierra, Tango, Uniform, Victor, Whiskey, X-Ray, Yankee, Zulu. So that's the phonetic alphabet. The police have a different phonetic alphabet. I'll post that one as well. And the only reason I use it is to clarify the letter that I'm talking about. So when I'm talking to you about hex, I'll say 2 Alpha, 2 Bravo, 2 Charlie, 2 Delta, 2 Echo, 2 Foxtrot. For those of you too young to remember or who aren't into dancing, Foxtrot is an old World War II era dance. I'm going to scroll down a little ways, clear to the bottom to 255, and I want you to notice now that 255 in decimal is the same thing as all ones in binary, which is the same thing as foxtrot in hex. Control home. Now let's talk about octal. So octal's weird. Instead of doing a base 16, which means we're going to shift every 16 numbers, it's base 8. We shift every 8 numbers. Octal was used back in the mainframe days. It's very good for reducing the amount of numbers that are needed for something, because back in the day memory was really expensive and you had to cram a lot of things into memory, and so programmers had to be very careful about that. Today we use octal for certain purposes, and one of the purposes I'll show you in a later Linux video. Super interesting. It's definitely, what do you call that when you're playing a game? It's an Easter egg for sure. Anyway, let's do this. So I'm going to start in and I'm going to say equals des to octal, base 8. And what I want to do again is point to cell A2. I put in a comma. Now in the case of how many numbers I want it to carry out, I only need 4 because this thing is going to shift again after every 4. So let me hit enter and then suggest the autofill. Yay, I love that. Now watch this. In octal we start counting 1, 2, 3, 4, 5, 6, 7. 10, 11, 12, 13, 14, 15, 16, 17. 20. So it's counting over. It starts counting again after every 8. Now when we get to the bottom of 255, I want you to notice, and this is very weird, that in decimal 255 is 255. In binary it's 4 ones. In hexadecimal is foxtrot, and in octal it's 0377. Okay, that's about that for that, but what I want to talk about now is binary. And I'm going to fill this sheet in. I can create a sheet and upload it to you, an Excel sheet, when I go ahead and do this movie. Or you can do it on your own to try it and see how it works. The first thing I want you to know about binary is we start counting from right to left. So we need 8 slots. So I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8. Now this first cell gets the number 1. This next cell to the left gets the number 2, and then 4, and then 8. Have you picked up the theme here? 16, 32, 64, and finally 128. These are the values that each one of these bits can have. So this is the first bit, second bit, third bit, fourth bit, and so forth. And so they are raised to a certain power. So if we say that we have from 0 to 1 here, this is 2 raised to the 0th power. Let me show you what that looks like. So I'm going to say equal 2. I'm going to type in a caret, which is an uppercase 6, and then I'm going to raise it to the 0th power. Notice that the calculation is telling you, okay, that's the number 1. That's correct. Now, here's the secret. When we're working in binary, binary is either 0 or 1. It's a base 2 system. So the power of it is that we can raise things to the base of what that particular bit area is. So what I mean by that is here is bit 1, this is bit 2. We can do this same thing. So we can copy this and we can say equals. Now I'm going to say 2 raised to the power, caret, oops, I did 2 raised to the power 1. And we get the number 2. So this is 2 raised to the 0th power. This is 2 raised to the 1th power. Anything raised to the 1th power is itself. Let's do just a couple more and then I'll pause the movie and fill in the last 4. So this is a third position here. Let me go ahead and type in equals 2 raised to the 3rd power. The 2nd power. That's going to be 4. This is the 0th position, 1st position, 2nd position. 2 raised to the 2th power is the number 4. Now we've got the 0th position, 1st position, 2nd position, 3rd position equals 2 raised to the 3rd position. I type in S, don't I? 2 raised to the 3rd position. This is 8. Let me finish this up, okay? I'll be right back with you. Okay, now if you look in the upper left here, you can see my formula. Here it is right here. And this is what, excuse me, I need to get rid of that. I shouldn't put that in there. And as I scroll through here, you'll see that every time I move to a new cell, the math goes up 1 number. When we get to the end of it, it's 2 raised to the 7th power, which is 128. Now let's add all of these up and see what this comes up to. One big point you need to remember is that we are talking about the 0th position. Computer people often start counting with the number 0. And so this is the 0th position, 1, 2, 3, 4, 5, 6, 7. That's going to be important to you. And let's go ahead and add these numbers up. So I can click the summation button right here. It's the epsilon symbol. And what it will do is I'm going to sum these numbers. And I'm going to sum from A259 through to H259. So A259 colon H259, like so. I could paint that in as well. Let me show you what that looks like. I'll get rid of that. I'll say equals sum, left parentheses. What I'm going to do is I'm just going to scroll over here to get my first cell, hold down the shift key, right click over to get my last cell, put in a right parentheses and hit enter. And lo and behold, look at that. It equals 255. Well, that's amazing. So we know now that 8-bit binary, the max number we can get at is 255. 8 ones in 8-bit binary, which is a base 2 system. Hexadecimal, which is a base 16 system, is Foxtrot, Foxtrot. And 0377 in Octal is your Octal system. Now there's one other thing I want to show you. This is the Windows calculator. You can just click search, type in calc, and the calculator will come up. I'm using Windows 10. Love Windows 10. On the Mac, there is a calculator. I don't use a Mac, so I couldn't tell you how to get to it, but there is one. And I'm going to click the hamburger menu here. This is called a hamburger menu because it looks like two buns with a piece of meat in between. I'm going to click the hamburger menu, and I'm going to go to the programmer calculator. This is the coolest thing since sliced bread. So let's say that you want to find out what the decimal number here. Let's say that we want to find out what 1344 is in hex or in octal or in binary. You type in 1344, you click which one you want, type in 1344, it automatically converts it to hex, octal, and binary. And so that's very, very cool. Now it's showing the binary to you in 4-bit nibbles here. So you'll need to get used to that, but this is incredibly cool. And then you can take and you can do some other operations like bit shifting and bitwise, which are a larger topic for another movie. I hope this is helpful to you. You need to know all of these systems, put them to memory. We'll be using them later on extensively, so let's get used to them. Hey, thank you for joining me. I had a lot of fun. Talk to you later. Bye-bye.